I've also got the power supply module installed. I'm just doing the case side of things now. I've still got to do the buttons. So what I've done is I've cut a piece of Perspex. I've got some 80 by 80mm Perspex sheet, 1mm thick. I've shown this in mailbag before, and I've just cut this in half to make 40mm, and that fits inside here. It's just inside there like that. You can see I've already taken the tape off one side, so I cut it first, scored it, and I cut it, snapped it. What I've then done is I've used that liquid nail varnish, transparent nail varnish, which I showed in the previous mailbag as well. I've gone around the edge of the housing and then basically glued it in with that. So obviously that's got to now dry, and I don't know how waterproof it's going to be. I'm just trying to make it splash proof, so it should bond quite nicely. And once I've got the thing built properly, I'll actually run some more around the edge on the inside to form like a bead around the inside as well, just to give it a bit better chance. And then the idea then, I get the display module, which will sit in there, and that'll press against it and help hold it in as well. The display isn't dead flat on the back, it's got these little bits sticking out. Okay, so what I'm going to do is that'll stick on the back of the display like that, and just cushion it, and hopefully these won't penetrate through. They might, but I'm hoping that the thickness will be okay, it'll do the job. And that's starting to go there. I've also got these plastic strip on the still as well. So I'm just trying different things out. I mean, this probably isn't going to be good enough. I do have some even thicker stuff, which is about twice as thick again. Again, I've shown these mailbags before, but I'm just trying to get some kind of buffering on there to cushion it. But I know the display is going on here. There for the holes, like that. Okay, so that's definitely sitting on there like that, and that will then go on there and be screwed down. But I've also got to put some spaces in here to suit. You can see the gaps in there, even with that kind of mat. Right, see that gap in there and that mat there cushioning it. So you can see I've got to be careful about shorting things out. I've got to be careful about making sure that any kind of compression is not going to penetrate. So I might even use double-sided foam to actually stick it to the back, but I don't want to do that yet until I've actually got the thing working. I know it all works properly. I don't want to be trying to peel foam off afterwards and trying to troubleshoot. So things like that. But you can see I've got to get some spaces in there, standoffs there. Right, so I was expecting to do that. That's not a problem. I do have some standoffs which I can actually probably put in those standoffs. Screw the standoffs into those standoffs and then use those. And then I can set the height up. If I can get it right, I can probably get it so it's not putting too much pressure on the display, it's just being held nicely in place. And once I get it all lined up and settled, then I'll solder the display on those 4 pins there at the back. Alright, so those jumpers there, I've got to do those and figure out the interface for the keyboard, which is going to go in here. So I've got to decide on how I'm going to do this linking here. So I've allowed for being a 10-pin IDC. That's what I was planning on using. It's a bit bulky, but I could go sideways with this one. I've allowed for that, maybe up with that one. I'm not quite sure how I'm going to do that part yet. Depends on the spacing on here. I've also got to stand this off as well to get the button height just right for the front panel. So this also needs to be stood off about, a certain amount. I'm not sure what that amount's going to be yet. It might be a couple of mil, might not be much at all. I'm also I'm going to be putting a plate on the top as well as a housing for the surround for the buttons. Nice little trim plate there. So these boards are supplied to me free of charge by PCBway. Make sure you go and check out their services. I've always been happy with what they do. I've purchased boards from them in the past myself, so go and check them out. Follow the links down below. This keypad, I've got to cut this piece here out, that whole section. I've got to cut that out because that's going to be far easier to cut that whole piece out than to cut out 9 buttons individually inside this piece, because that's just going to be a pain getting them lined up properly and get it all nice and tidy as well. That'll take ages. But it's far quicker for me to cut this whole section out so the buttons protrude through that whole section, which is what I've designed it to be anyway. Then I'll make a facing plate which will go on the top like I did on the original prototype, where I've got that 3D printed panel which goes over the top to surround the buttons, and just like a nice little trim plate. So that's the plan. Actually, what I'm thinking about now, I knew I'd sort of figure these things out as I come to these stages of the process, is I think I'll make a 3D printed section for 2 reasons. I think if I rely on something soft to go between these 2 faces, it could be a problem. It's going to gradually compress and it may short out later on down the road. It may not be for a couple of years, but it could happen, right? So if I make a 3D printed plastic section which will go between these instead, that won't be an issue. Then it'll just separate them nicely and I can go around the profiles on here to miss the lumps, and it'll sit and support it nicely without being a problem. And the other reason I want to do 3D printing is that I need to tidy up the way this is going to look in the display, right? because the housing is much bigger than the display itself, as you can see, you're going to be able to see the surrounded display, you see the circuit board and that sort of stuff. That will be visible through the perspex. I don't want that. So what I think I might do is also 3D print a bezel to go around this, and just to go around the edge of that, so I'll probably make it the same width as this piece here, and this will just sit over it, just very thin, maybe 1/2 mil or so, just on this front edge, and step it down so it rests on the circuit board. And that'll also help to take some stress off the glass as well, because you're pressing on the edge of the glass and you can actually cause artifacts on the screen if you're not too careful about putting too much pressure on it and you screw it down, for example. So you have to be a little bit careful, you only have minimum tension. So if I do all that, that'll press against the circuit board, takes the pressure off this, and it gives a nice trim, which will then be a bit better for the display. So it should then be black and it wouldn't look out of place, and just look a bit nicer, because I want to try and get a nice professional finish on this. I don't want to see circuit boards and things like that. I think that's my next step, is to go and design some 3D printed stuff and get that 3D printer going, and then I can carry on with the rest of it. Okay, it's been another day. I've been pretty busy with other things, so I haven't got everything done that I wanted to get done, but we're getting there. So you can see I've got the housing basically built. I'll pull this apart, I'll show you. It's not actually bolted together yet. So I've got the button board built already. I've already made that. I thought, well, I won't bore you with that. It's just the buttons being soldered onto this board. There's very little on this board. I've got the buttons. There's the jumper block down there, the header, and a resistor, single resistor just here, which is for the LED. Right, all the other ones I've got resistor placements, but I don't actually have any connections going to any of them. So at the moment none of those are used, it's only this one here. So as you can see, I've made a little IDC cable up, ribbon cable with 10-pin plugs and stuff. So that's nice and short, just only goes as far as it needs to, keeps it nice and tidy. And that's using some 2.5mm screws. What I want to do is I'm going to 3D print a panel to go over this, make a nice trim that covers it up like I did in the previous prototype. Although, you know, I do quite like the fact you can see the name and stuff through there and the board. I do quite like that. I've got to clean the flux up. That's bad. I haven't done that. What I was doing yesterday is I've done a couple of things. Let's just get the board back off. So I changed these headers and stuff on here. Focus. Here we go. So I've got these two. What are they called? I've forgotten. That connector type. I've forgotten what they're called. Anyway, it's an IDC connector here, which I put on there as well. So I changed these headers around a little bit to be more what I want to have on there. This board's not quite finished. I've still got to put on the connections for the main power coming in and do testing before I plug anything into it to make sure I haven't got any electrical problems on it, because don't forget it's a brand new revision board. I could have made a mistake. The other thing I did is I made a bezel for the display. It looks a bit ugly right now, but it's okay because it's behind perspex anyway. Now I actually did a hint that Ian Scott Johnson mentioned to me once when I was saying about the surface finish of the 3D printing I did wasn't look very good. It's quite rough because there's the PI sheet on the bed of the printer, and he said stick down some Kapton tape. It's like, well, that's a good idea. So I stuck down some Kapton tape. Now it did give a much nicer appearance. It's actually, you know, quite glossy, as you can see, but because the tape didn't stay down perfectly, I had a couple little creases in it that showed up, you know, a couple little bits. That's actually a defect in the bed, that big dent there. The bed, the PI sheet's actually got a bit of damage to it, and it's actually lifted up, it's got a lump. So that's what that bit there is, it's underneath Kapton tape. Right, so that's just the bezel, just to tidy up so you don't see the circuit board, you don't see electrical connections, stuff like that. So when it's actually in the case behind the perspex, you won't see anything apart from this bezel, which is better than what you could otherwise see. I made it to fit the OLED, so it actually press fit around the metal bezel of the original screen. So it just slides on there and it's basically just sitting there, it's not actually doing it, it's just sitting there. And I've got a little cutout here for the connections at the top, and also got one at the bottom here where the screen actually bumps out. It's sort of flat and then steps down a bit in the middle. So I've got little cutouts in there as well. So I can actually bring this face here up very slightly. You can see there's probably 1/2mm or so of a step between the bottom edge of that bezel and the actual screen bezel. The other edges I've got pretty good, they're pretty even. I think they're about 1/2mm or so, maybe 1mm on those three sides. But this one here is a little bit low, so I probably could tweak that one and make it slightly bigger. You can just see in the light there, you know, it's pretty close. But that's what I built yesterday, just that little bezel there. And I also made, this is the first one I did, a spacer bracket. Okay, so this is going to go behind the OLED display and this board so it spaces them apart. And I was going to use this this pad stuff before, which I mentioned, but I've changed my mind about that. I just don't trust it to stay good for a long time. So I thought, right, I'll 3D print something. This is just a prototype one, that's the first one there, which just gave me the basic sizing and everything. Is that the right way up? Yes it is. So that was sitting there. And I had lots of issues with strings. This is PETG I'm using, and I haven't done a lot of PETG. I've only done a little bit of PETG printing. I've only recently started using it. I was using PLA before, and I'm still trying to get my settings right. My settings aren't there yet. So yeah, anyway, I had lots of stringing on this one, so I hit it with a hot air station to try and melt the stringing off, and so I got a bit of a bad finish in places, but it's just a spacer bracket, doesn't it? For some reason it's a little bit short. I think it's shrunk or something, I'm not quite sure. And so I ended up, I just heated this back a little bit and stretched it slightly just to get all the holes to line up. Okay, but basically that works, and the reason I've got these weird protrusions is to support the OLED display as much as possible, so it's not just on the very edge on the ends. I'm trying to support it wherever I can. This one I've just made today. This is like the next revision. As you can see, I've lightened up a little bit, put some holes in that sort of stuff. And this one I made a little bit bigger, but this time it's actually a bit too big. I've gone a bit too far with it, so I've got to, the next one I do, I have to probably come down by 1 millimetre. I made it about 2 millimeters bigger, and I've gone too far. I need to come back. I need to go with 1 mil bigger, and that should be right then. But you can see I've got some more supports through here. After I've got the prototype, I can see where I need to put the supports. And so I've got them in this corner, this corner, this corner, and this corner. And here you can see, I hope you can see, that's actually really thin just there. That steps in, and that allows for the OLED parts on the back there. Now that thickness there is 1.5 mil. This is 4 mil, and actually brings this to basically be just about touching this ribbon connector here. That means it's got a bit of extra support in the centre too if it needs it. Not much, just a little bit. And if I drop this in place. Now this one I had a problem with. It started lifting off the bed when I was printing. It printed for an hour, so it's not perfect. This corner here lifted off, and this end started lifting as well. So this end is the good end, which is right, and this end lifted off, and you can see it's lifted away from the bed there. It's come away. That was just on the PEI sheet, that wasn't on the Kapton. Might have to try and tweak settings to get that better. That's all fun of 3D printing, isn't it? Finding what works, what doesn't. But anyway, that's the other bracket which I thought I'd do. I'll revise that a bit more, and next time I'll try and get it to stick to the bed a bit better. Might try some glue or something next time. Some people say hairspray, but I don't have any hairspray because I've got hardly any hair. Alright, so that's that assembly. Alright, so that all sits in there. And I don't know if you can actually see through there or not with the spacings. Probably can't really see. But that's basically all seated out just nice. There's a gap at the back there, and these are sitting nicely on here as well, those spaces. So that's all beautiful, right, as far as that goes. And also the ribbon cable then just slide around and drop straight into there. Now these are very slightly offset. If I spin around, you can see. Maybe you can see it's slightly sideways there. I wasn't too worried about the alignment on these because I knew I was going to be using a flex cable like this ribbon. So I could have put that connector there slightly further that way. You know, probably, I don't know, 1 millimetre or 2. Wouldn't need much just to get that straight. I could have done that probably, but I lined it up to make it easier to get the connections to these pins on. I lined it up to these more easily. That's what I based it upon. And this one here I couldn't really move because of the way the switch is set. So I think we're pretty close to actually doing some electrical testing on this. And I need to basically plug this in and make sure that the pins go to the pins they're supposed to go to. I also have to rewrite a whole bunch of code to allow for this new board, but I'm pretty close to actually be able to power this thing up. So things I need to change is the code for the keyboard, because I've changed that, obviously different pins now. I've shifted things around slightly. The buzzer's got its own output. The LED on that button there has got its own output. I've given dedicated outputs that were shared before on the original board. I've got the voltage sensing, which goes to a pin over here somewhere. I can't remember which one it is. So I've got to do code for that as well. So basically I've moved things around and added some extra features, so I need to rewrite code to allow for those things. The one I'm most keen to get working is the voltage reading, so I can see what the battery state is like at any time. So yeah, we're doing alright there, I think. And also once that part's all finished, I can do the bottom of the casing, this half. Now what I've decided to do as well, I think I mentioned it, did I? The lower module here, which was designed to go on directly on that board, and the connector over here, they're designed to go right there. But I wasn't happy with the fitment, so I decided to run it on a lead. But this lead I think is a bit long. I'll have to see if I can get some shorter ones. It might do for the time being. Yeah, I have to get some shorter leads. Then I'm hoping I can actually do something like stick it straight in the back. Another thing I thought about was using a little flying lead instead. I was actually tempted to remove this connector here and put a little mini coax with those, I forgot what the connector's called now. But anyway, it's got SMA on one end and it's got a little click connector on the other end, little press-on connector, which I completely forget the name of right now. I could cut that off and just run the coax to here and solder the coax straight on, and then I can actually put the antenna on the back here, like that, right there, and that actually be really nice just there. I may even be able to squeeze it up there in that gap out there, so it's sitting off the top of the board. I was very tempted to do that. I mean, it could just do it. There's an ejector pin hole right there. You can see the round disc. That's an ejector pin. It's like a moulding mark. That's the pin which pushed the thing out of the mould when I finish making it. Oh, that's great, because that means that will be bang in the middle, right? That'd be millimetre accurate, well, tenths of millimetres accurate. That I could use the mark and just drill straight into that ejector pin hole, and that'll put the antenna right there. I can actually then put the antenna on the top instead of on the back. So I'm not quite sure yet. But this is the prototype case. I'm not too worried about messing it up. I don't want to mess it up because these things are $15 each. So, or was it more than that actually? It might be more than that. Probably going to have to stick on its side or something like this, going through the back plate there, like that, and mount the antenna straight at the back, and then run this cable up to the board, which as you can see is going to be massively too long, so I could definitely make that shorter. I don't have anything to make these cables shorter apart from cutting them and splicing them, and that's a bit of a pain. If I was doing that, I'd just be soldering the wire straight onto the circuit board and having a plug on this end kind of thing, you know. Yeah, so I'm looking at maybe sticking that through there, or maybe using a flying leader on sticking the antenna on the top. I've also got the SD card here I've got to do something with as well. This has got to be stuck down somewhere and mounted. I don't really want to have anything directly on the bottom of the case, like electronic wise, because this is going to be sometimes an environment where it may get rained upon. If any water gets into the case, it will obviously sit on the bottom, right? And so I'm kind of mindful that I don't want any electronics sitting directly on the bottom of the case, because that way if it does get in, it won't matter. The only thing I'll probably have sitting on the bottom would be the battery holder, and if that gets wet, well, so what? It's not going to matter, because it won't get onto the batteries themselves. Not about a lot of water getting in. It's going to be, you know, dampness getting in, and maybe a slight film. You wouldn't get much water in it, so I've got to sort of consider that. And also I need to figure out what kind of battery arrangement I'm going to use. I'm going to use individual holders, whether I'm going to use double holders, whether I can fit 2 double holders in. I'd like to put 4 batteries in. It then gets pretty expensive when it comes to batteries. These things are a lot of, I don't know what they, $15 each I think, as batteries are, the decent ones. You can get cheap ones. I could put in 4 rubbish ones, couldn't I? It doesn't quite fit in between those, but it's also a matter of how this is going to fit against the keypad section, you know? So I've got to figure out these little details about exact layouts inside, because also I've got to put this in, I've got to put this SD card, I've got to put the module in for the wireless. The ESP32 will also be sticking down from this case. Once it's mounted on it, it will stick down lower, so I've got to be careful about the heights within this section of the case. And I've also got to put the BMS in there, power switch and DC socket as well for charging it. But a lot of those things I'm going to probably put straight on the back panel, and it's been 17 minutes to be waffling. I should really push pause. So I've been busy doing printing and stuff, and I've got some more progress. This is another day later. So I've done another version of this. Because of the previous issue I had with the spacer lifting off the bed. See, it's a bit bent there as I showed before. What I decided to do is modify the design. I'll show you a bit closer what I've just done. So it's a bit glossy, it makes it hard, but can you see how those slots have cut into it? So all these braces have got slots in. What they do, the effect of that, is it reduces the shrinkage, right? And the issue is it lifts off the bed because it's got shrinkage, right? So as it gets thicker, you've got this bit which is already cooled, and it's still shrinking because it's still warm, right? But you're still going to get shrinkage. It could be 0.4% or more, you know, depends on the material. And then it all shrinks, and that's what makes it curl up, because then effectively the top edge becomes shorter than the bottom edge, right? Because it's warm and then it shrinks, and the hotter it is to start with, the more it will shrink as it cools, okay? If what I've done by putting these little slots in here, as you can see just in the profile there in the silhouette, alright, that creates tension breaks. So the only curving section is going to be that piece which is solid along the bottom, which is 1.5mm. That's the height I've done that at, same as this piece here. So that's 1.5mm with all these blocks on top of it. These blocks are only there for spacers anyway, so it's not that critical. It's not there for strength or anything. And what they do is they stop it from being curved upwards when these upper layers are done, and that's kept it dead flat. Well, maybe there's a slight curve in that one, but it's, you can't. I couldn't put slices through everything, You know, this slices through a lot of it. You know, slices through. Yeah, I'll do that angle there. You can see it there. I've put slices all over the place, and each one of those means when it shrinks, I mean, you still want to get some shrinkage and some level of trying to peel, but it's only going to be across this small area instead of across this whole area here. So that means the shrinkage is much less of an issue. It's basically a workaround. The shrinkage is still there, except I've managed to isolate into these little pockets between each slot. That's the plan anyway. So it worked fine. And today I was printing this out. I made this yesterday, well, I designed it yesterday. I've been printing it today. It's taken about 6 hours because I'm using really fine resolution and going quite slow. And unfortunately, what my intention was to do it in white and then print with black filament to make all the lettering and these button outlines. So I paused the printer as it started doing this. I came over and it's realised it had already started printing them, so I thought, oh, I better stop it. So I paused it, changed the filament over, resumed it, and what it did, instead of going back to where it was, it just scraped right across the whole thing, and it's got a big scrape mark across here. It's messed up the menu wording and things like that. You can see it's a bit scraped through there, and then it came over here and scraped through this bit. So I was like, oh, quick. So stop that. That wasn't going to work, so it's quite disappointing. So what I've had to do instead is just go over with a bit of pen and just highlight the embossing there. Embossing? It's not embossing, is it? I thought it was called anyway. The letters are standing proud. These brings the lettering out of that. Unfortunately, it's a bit messed up over here because of the nozzle running through it. Quite annoying. So at least I know next time, don't do it that way. Just pull the filament out and shove the next stuff in, and you know, whilst it's printing, and let it gradually change, because that way it wouldn't have messed it up. Which is what I was planning on doing originally. Anyway, never mind. That's the front plate, and that fits perfectly. I will probably print another one out and do the other technique, and this is just a prototype again, but I'm fairly confident it'll be alright. That's the progress I've made since yesterday. Not much, you know, it's probably working full time and trying to do this in my part time and videos, and yeah, anyway, we won't go there. So, life is busy. So also I put some little standoffs on here, I don't know if you can see it properly. This little post sticking up just there. I've done 4 of those, and that's to help the alignment inside the case, because the screw holes in the case, obviously the protrusion of the posts, that sits on those, so it will actually help to centre it all and get it all lined up. That's what I'm trying to achieve at least. So yeah, it does actually work. Just line it up there like that, and that's all sitting there just fine. Made a bit of progress. I've been working on the code today as well, whilst the 3D printer was running. There you go. It's sitting there. It's doing a lot better now. So I've done some changes to the code to allow for the modifications I've done on this particular board. This has been a big project. Yeah, it's been interesting. So I'll be glad when I've got this project finished. It's just taken forever to get it done. I really need a break. I've been doing this for 3 months of my spare time, doing this thing and designing things and trialing, writing code, rewriting code again, rewriting code, optimizing things, you know, allowing for a situation that can happen. So yeah, it's been a real pain. But once it's done, and I can move on and get back to doing other stuff. But yeah, it's coming along. As you can see, it's looking a lot more professional now. You know, so if I stick them side by side, there's the prototype, which was my original design, which is what I was going to do. You know, when I actually built one, I thought that looks really ugly. I thought, well, it's fine. It's a prototype. I can still use it for testing, and that's worked perfectly fine for doing testing. I worked out what I actually needed to do and what I needed to handle and that sort of stuff. You can see I printed this one out. Okay, quite nice. So yeah, I mean, got this one, and this is the. Obviously, let's put the bottom case on too, so give you an actual real scaling. There they are. You know, so this is, you know, probably half the size really. Certainly, it's certainly narrower, shorter, thinner. So it's probably about half the volume. So, and it looks a lot better, you know. So obviously I've still got a lot to do on this thing yet. I've got to do the antenna system and charging circuitry and batteries and stuff like that. It's probably another couple of days away of work for me to actually get this prototype working. So I'm not going to get it done in time for this weekend, unfortunately. I wanted to get it going by the weekend because I've still got the problem of there being buttons missing. Show this again. So those 2 buttons there, I don't have them yet, and without those I can't build it. Well, not finalised anyway. So a little bit further progress on this thing. As you can see now, I've got it assembled. I've got the 3D printed panel on there. It's the screens in, everything. The buttons are on here. I'm not completely happy with these buttons yet. Well, I'm not finished with them. I want to put some little button covers on there. So I've got some proper push buttons rather than just these little stalks sticking out, but I don't have them yet. They're coming from China and they've been delayed, so they're not here yet. So for now I just have to use these, but that's okay, I suppose. As you can see, I've 3D printed this, and this is in 2 colours. I did a black PLA first on here, and then I changed the filament as I started printing the text and these raised edges around the buttons. I swapped the filament out and then went to orange, obviously, and that ties in nicely with the orange logo and stuff up the top here. Well, it's actually gold. It's actually a gold and black. I figured this in my bag recently. I got some Brother P-Touch tape, and I got a gold and black, and so that's what I've put down here just to give it a bit of a detail there, and it kind of matches. It's close, you know. This was actually a more goldy colour, this orange, because it's got the black behind it. It was, you know, semi-translucent material. When it was quite a thin layer, it was actually very close to this colour here, because it made it darker. And as it's put thicker layer on, it's got, you know, a bit more orange. So yeah, it works. I've had to do a bit of coding with the battery voltage level stuff because I wanted to measure its own battery voltage. I had a lot of trouble getting that working. I spent a lot of time trying to get that going because I was based on a 3.3 volt input range on the analog pen using the Boonton ADC, and the thing just wouldn't read right, and it's really non-linear, and I could not get the thing to behave properly. I got it close, but then it was not a linear scaling by a long way, like a half a volt difference on the readout. It's a long way out, and it's just not good enough. So I ended up turning off the attenuator functions in it, so there's no attenuation, 0 dB attenuation. What's the code for that? ADC set attenuation in brackets 0 dB or something like that. There's some code for it. Look up the ESP32 code, you'll find it. So I did that, and then also, because of the lower attenuation, well, no attenuation, means it's now only available for 1.1 volt scaling. So what I then did is change the resistors on that board for the voltage divider. I'll get one out, I'll show you where they were. So they are over here. So I changed it. I did have a 510k and a 250k volt. I actually had a 240k because that's what I had, and I allowed for that. But what I've now done is I put a 240k up here in the 510k spot, 240k there, and I put a 22k here to change the ratios, and that gives me about 1.1 volts, just under 1.1 volts maximum range if I were to go to 3 batteries. I made that change, and the attenuate settings also changed the ADC width as well to be 11-bit instead of 12-bit, because that can apparently help to reduce noise and erratic readings. And I did all those things, and we now have this. It works. So that's all good. It now reads correctly. I've checked the battery voltage. What I did is I hooked up my power supply over here to the board and injected voltages and just saw what it read out, and I actually had a bit added on to the side. I'll show you again. So over here I actually had it displaying the digital reading, so the actual reading it's seeing on the analog pen, and then based on that reading I could then calibrate the display to read the correct voltages as per the power supply. So I put in 6 volts, and I used a mapping function in the Arduino IDE, and I mapped the 6 volts to the digital reading, and then I did 8.4 volts, mapped that, and then that gave me that range in mapping, and it's actually pretty linear. It's pretty good. It's a lot better now. And then also I took that back off the display again afterwards once it's finished. And also checked the BMS system. I should go and get one, I'll show you. So these are the BMS. I use one of these modules. As you can see, I've got a stack of them on this board here. And these are 2-cell BMS. So you've got battery positive, minus, battery middle, and power output here. This is what I actually used, and I didn't actually test the dropout voltage. I'd assumed it was going to be 6 volts. It's not, it's 6.3. Below 6.3 volts it turns off to protect the batteries, okay, which is exactly what it's supposed to do. And so what I had to do is I hooked up the power supply across the battery terminals, and I just tried different voltages, just gradually dropped it down until the thing shut off. Once it shut off, I knew what the bottom end cut-off voltage was to protect the batteries. So then I set my battery percentage reading on here. So I'll turn on again to show you. So over here, that reading there, at 6.3 volts, that's 0%. So I've got a correct scaling for the battery percentage. I've also done a bit of a tweak there, so it will say 100% if it's above 8.2 volts. So it gives a bit of a tolerance there, otherwise as soon as you turn it on and got a bit of voltage drop, it won't say 100% even though they're fully charged. So I've done that. So anything above 8.2 volts will show 100%. After that, they'll stop dropping down. So I've skewed it upwards very slightly, only on a percentage wise. The actual voltage is accurate. So yeah, these little BMS seem to work okay. I didn't have a lot of room in here. I did want to put in 4 cells if I could, but I can't fit 4 cells in there, not easily anyway. I might be able to cram them in for use a couple of individual holders as well. But if I do that obviously I need to change the BMS to be a 4-cell BMS. I could definitely put 3 cells in, so that may be a possibility. I just want to see how this goes first with 2 batteries. If it lasts fine on 2 batteries, then that'll be right. I don't have to do much more than that, so I might be okay. 2 batteries might be enough. If not, then I might put a 3rd cell in there and reconfigure it slightly to have a 3rd cell, and then it'll give me 50% more runtime in theory. We'll see. I don't know, but like the charging circuitry was on the side here. I've got charging here, got the SD card over here, so I can pop that out because it does backups to SD, so that's why I need it accessible. Let's get it back in the slot instead of missing it. But the charging circuit over here, that is an adjustable buck converter, so I can put in high voltage and just adjust the buck converter to suit whatever cells I've got set into it. So that's what I've got there. I've allowed for changing it still in the future. It was quite tight to cram it into this case because I've got a lot going on in this area here, because I've got the display, I've got the ESP32, I've got the main board, I've got the interconnects to this board here, I've got the LoRa module and charging circuitry and stuff like that all stuffed in here. So it's all in the back end of the case, and also I've got the batteries sitting about here, about midway down. So I've got a bit of space in the front. If I wanted to put another battery in the front, I could definitely do that. Anyway, it's working and it's going well. So then I did the prints. That was the first print I did of this design. So this drops straight over anyway, that does fit. But that was just a prototype. Then I did this one here, and I had this printing overnight, left it going overnight, but I had it going really slow. I slowed down to like 50% speed to try and catch it in the morning to do the filament change. Anyway, I got here a little bit too late, probably 20 minutes late. I saw it's printing, you know, most of the text was done, and I quickly swapped the filament over. And I don't know if you can see it on camera or not, but there's a little bit of orange just on the edge there. That's all I got, was just a little bit of orange around there. Didn't quite get there in time. Don't know if you can see it. But yeah, I didn't get there enough, so I had to print it again. Even though I printed absolutely fine, it didn't have the colours for the text and the outlines. So I had to do it again, which is what this one is, which is what it's supposed to look like. So there's nothing wrong with this apart from that. I might see if I can maybe paint it or something, I don't know. Try and recover that one, rather than printing it again. But it's about a 5-hour print, because I'm using quite fine layers and stuff like that in order to make sure the text comes out reasonably nicely. If it wasn't for the text, I could go a lot faster. But anyway, it works. So coming along. I've got to do some more tweaks to the code on this yet. So although I've got the LoRa on here and I've designed the board to allow me to turn the LoRa on and off, this isn't actually used yet. I've just got it turned on. So once the power powers up, it turns on the LoRa and the LoRa module stays powered up. And it's using about 25 milliamps all the time because of that. But I can control it and turn it on and off, but I haven't done that in the code yet, so I should actually get done before I go to use it for the first time. I do need to kind of prototype that bit. I've already done it on this thing here. This is the keyboard interface, currently charging it up. This is actually going to end up in a case like this as well at some point, but obviously one of the buttons, it'll be the same case but with a display. That's the same displays on there. Then it'll at least be a bit more watertight because it's got a big hole and stuff like that. I can run a cable to the bottom of the case and things like that, so it's splash resistant. This one here does turn the LoRa module on and off, so I know it's capable of doing it, and this has been modified to allow me to do it. So I need to write that into the code yet. But once I do that, it'll save a little bit of power as well, which will help the battery usage. So what I might do, once I've actually got the system finished, is I'll probably record some video at an event showing this being used, showing this being used, and actually show how it's actually used in real day life. Right? You know, what it's actually been built for. It's one thing me showing you here on the bench here and trying to explain stuff and demonstrate little bits and pieces, but if I actually show a bit of video at an event showing what it's actually used for, then it'll give you a bit more context about what it's actually being done for. So, some people which are familiar with dog agility will understand what it's for anyway, but most people wouldn't have a clue because they've not been exposed to it.
Okay.
Good to go.
Judge? Competitor?
You don't need me in there, right?
The actual scribe next to me.
No. The virtual scribe, you mean?
I wish
Three. Len?
Because you got that as well.
Thank you.
I just need my tray bag at the end.
I've now got merch shelf stuff down there in the description. I've got my merch shelf with all my bits in, like my cup here. That's in the merch shelf and things like that. I've finally got to that because I've got 10,000 subs now. So yeah, I see people to buy stuff. Yeah.